Okay, 2-2 polynomial functions of a higher degree is the order of the day for tonight's homework. Let's take a look. So, last night we talked all about quadratics, which are parabolas, and so that's all x squareds. We're going to move on now to higher order things like x to the third, x to the fourth, x to the fifth. All of these things, including x squared, the quadratic, which we did last night, are all called polynomials. All right, so a couple rules on polynomials. First thing is that we cannot have any breaks, holes, or gaps in our function. So this piecewise function here, where it splits up and we have a gap between the two parts, this would not be a polynomial function. It's still a function, just not a polynomial function. And then rule number 2 is that every point on our polynomial functions need to have only smooth, rounded turns, like we see in this graph here. Nice rounded turns. The absolute value function is not a polynomial function because it does not have a smooth turning point. It's a sharp turn there. All right, so we'll take a look at some higher order functions here, but we're going to have a couple rules for even and odd. When we have even functions, x to the second, x to the fourth, x to the sixth, x to the 8th, x to the 20th, they're all going to have a similar shape to the parabola to x squared. They're going to have endpoints that both point in the same direction, and the larger the power, the flatter we are as we approach 0. So x squared here is a little steeper than x to the fourth. Same thing here. When it's odd, we're going to cross through the point 0, 0. A little bit shallower for our higher order functions, so we can see a little bit steeper for x to the third, and notice how it flattens off a little bit for the x to the fifth. Higher the power, the more flat you're going to see your curve. So let's take a second and sketch the graph of some functions. We'll start with negative x to the fifth. So what we need to ask ourselves, is this even or odd? This is to the fifth, so this is odd, so we know we're going to cross through 0. Now normally odds go like this, but since it's a negative, we're going to flip over, and we're going to be a little bit shallower than we would normally be if we were doing x cubed. If that's x cubed, x fifth would be a little bit flattened out. All right? Same drill here for x to the fourth. It's even to start with, so we're not going to cross through the 0. We're going to touch the origin point, and we are shifted left 1. So our vertex is here. We're going to come down, and because it's x to the fourth, be a little flatter than our normal parabola would be. So the dotted one would be the x squared. We're a little shallower, a little flatter as we approach 0 down in here for x to the fourth. All right, give it a shot for yourself on 17. Go ahead and pause me, press play when you're ready. All right, so A, we have a simple shift to the right of 4, and we are odd, so we pass through the origin, and in this case the origin is shifted over to the right 4. For B, we're shifted down 4. We go through it. For C, we are negative 1/4, so we are flipped over. And instead of going up 1 over 1, we're going to go up 1 over 4. So we're going to come in really a lot flatter than we normally would. And let me erase A here so I can put up D. And for D, we need to shift first, down 4, right 4. This is the new origin. It's shifted over, and it's just a simple parabola. I'm sorry, not a parabola, an x cubed function that goes through the point 4, -4.